Hey, what's up, everybody? This is Cam with Danomics. So, it's Friday, so I figured I should put out a little video here highlighting some capabilities in Danomics. So, what I've got here is I've got a 3D model that I've made of several properties. The one I'm showing right now is porosity, but we've also made models for all of the imported curves, so gamma ray, resistivity, neutron density, sonic, and PE, as well as other interpreted properties like SW, TOC, volume, clay volume, things like that. So now that I've got those, question is what can I do with it? Well, I mean, of course, yeah, I can make some pretty images, show here with my structure maps and spin that around and wow the boss with it. We can come in here and make slice views and stuff like that. But I want to show you a couple of other workflows that I think are pretty neat in here. So the first thing, I've made all these volumes. I have a whole bunch um, of horizontal wells in this area. So let me just show you the horizontal wells that I have in here. I'm just going to jump over here, and I'm just going to show all wells. Hit apply there. There's about 4,600 of them. Let me just drag that layer to the top. Okay, so you can see we have a whole bunch of horizontal wells in this area. Now, I don't have hardly any log data for these horizontal wells, just because they're sparsely logged, and wells only have gamma ray or something like that. I don't want to load those into my project where I'm doing my interpretation. So what can I do for these wells? Well, we can run what is a an extract flow here in Danomics. So what this flow looks like, we come in here and we just point it at our we at our an empty log database essentially, and then we say, hey, let's extract the data out of the model for each of these curve types for each of the models, and then we'll trim off some of the flat spot at the top, and then we'll write out a new log database. And I just ran this. Looks like it takes about you know these are in seconds, so about 6 seconds uh, per volume that I'm extracting from, and that's for 4,200 wells. Um, so we've done this whole operation here, like 8 or 9 different, actually 10 different volumes. Did that in just over 1 minute of calculation time. So pretty fast there. And what does that give us? That gives us this log database that we have here. So you can see that, we've got all of these modeled curves in here. I already have my TVD inclination and azimuth in these wells, but you can see that we now have our model curves. We're coming through the build, and then we get into the horizontal, uh, portion of our lateral here where it becomes much flatter. All right, well, I have that. Now what am I going to do with it? I'm going to jump over here to a petrophysical interpretation. I'm going to bring those logs in, which is what I've done here, and style up the tracks here. So here I've got my gamma ray curve that's shaded by the PE. I've got the deep resistivity, the neutron and density curves, as well as the sonic, and I've got my total porosity and my SW here. And these are all what was extracted at the model. Now that I have my Phi-T and SW, and I've also got clay volume and TOC, I could plug those directly into my cutoffs, try and get an estimate for, hey, over what portion of the wellbore was this, was it in net pay, for example, according to whatever my cutoffs or definitions for that are. So I think that's a really cool use case of how we can use these models to extract data into these horizontal wells. Give us a expected log signature there. And if we can do this for wells that are just proposed wells, where all we have is a deviation survey. And if you do that, then you can use that information, that extracted information, to help inform your pre-drill prognosis. What What would I expect at this location for the pilot hole, for example? If you're geosteering, hey, this is what I should be looking for if my model is correct. Um, so I think it can be really useful in that context. Okay, so that's one use case there. What's the other use case? Well, I've got, all these structural horizons in here, and I've got like 5,000 horizontal wells. I don't have time to go through manually and classify, which wells are in which zone. So what I'm going to do is I'm going to use my landing zone analysis tools. And what we do is we come here and we use our zone lookup flow tool. We tell it what structural horizons that we've mapped, and we give it our well headers. We then use our landing zone analysis tool, and we will write out all that data. In this case, I'm more interested in the Wolfcamp B and Wolfcamp C, so I'm going to, you know, really focus in on those, and I'm going to write out that database. And what do the results look like? Well, what it is you'll get at the end of the day is you will get the API number, whether it was evaluated, what the maximum inclination was, what the primary landing zone was, what your percent in zone, feet in zone, and the evaluated lateral length are. And what you can do is you can see, hey, a lot of these wells are 100% in what we're defining as the Wolfcamp B, but hey, here's one that's only 68%, 85, 86%, 80%. So you could start using this information to help ask questions like, how are these wells with lower percentages in zone performing? Are these wells underperforming expectations? If so, that might be a sign that when we're getting into some of the other zones that are adjacent to the Wolfcamp B, that it is leading to underperformance, and that maybe tells you that you need to more actively geosteer your well. Either way, I thought that this was a pretty cool example of how we could use our modeled structure surfaces and our 3D property models, and then you use that information to populate horizontal wells with log properties and to do landing zone analysis. All right, hope that was interesting to you. If you want to get in contact with us, just shoot us a note at sales@danomics.com, and we can have you up and running and doing this type of analysis on your wells right away.